multi-step inequalities, and then graphing them as well. I know I don't have the directions written up here on the board, but basically for any inequalities, we're going to graph them. Okay, so here's our inequality. The variable is actually on the right side. You could solve this as is and then get the variable to the left side in the very end, or you could just switch the sides right off the bat. There's a lot of different approaches that you can take right off the bat other than what we'll do. So here's what I notice. In parentheses, you have a d plus 1 on the right side and negative 4 directly in front. So you have to distribute the negative 4. You're only distributing the negative 4 on the right side of the inequality, so it's not multiplying both sides of the inequality by a negative. You don't reverse the inequality. So we have 8 is less than or equal to negative 4 times d is negative 4d. Negative 4 times 1 is negative 4. Now we could use inverse operations to solve for the variable. Add 4 to each side. 8 plus 4 is 12. That's less than or equal to negative 4d. D is being multiplied by negative 4, so we need to divide each side by negative 4 next. 12 divided by negative 4 is negative 3. Since we divided each side by negative 4, we're using the golden rule, where we reverse the inequality. Instead of less than or equal to, it becomes greater than or equal to. And then on the right side, just left with d. Especially since we want to graph this, it's probably going to be easier if we write the inequality with the variable on the left side. So d now is less than or equal to negative 3. These are equivalent inequalities. And this inequality, the inequality points to the variable. It does in this inequality as well. So now we can graph it using the last inequality that we wrote. 0 and negative 3 on our graph. D is less than or equal to negative 3. So we want to fill in circle at negative 3. Now that we have the variable on the left of the inequality tells us which way to make our arrow on the graph, to the left. All those numbers are less than or equal to negative 3. All right, so for the most part, with your inequalities, they're very similar to equations. So if you know how to solve an equation like this, then you should be able to solve an inequality. We have the variable on each side. We actually have like terms on each side of the inequality. 7k and negative 4k are like terms, so we can combine them. 7k minus 4k is 3k plus 6 is less than negative 2 plus 3k. And what you should notice here is you have the exact same amount of the variable on each side of the inequality. So it's like an equation when you have the exact same amount of the variable on each side. It's going to be what I call a special case. You can subtract 3k from each side. Then what we're left with on the left side is just 6 is less than, on the right side, negative 2. Now we have to think about that for a second. Is 6 less than negative 2? Maybe pause, think about it. A positive, so the 6 here is positive, is never less than a negative. So this is not true. This is never true, in other words. Kind of like if we had in an equation, 6 is equal to negative 2. That's not true. So since 6 is not less than negative 2, then our solution should be no solutions, or no real solutions. And then if I wanted to graph that, to graph no solutions, here's 0 on my number line, no number on the number line would work. So the graph would be basically an empty number line, or you don't do anything with the graph. 0 would not work. It's not a solution because there's no solutions. 1 is not a solution. So I have an empty number line. If it were the opposite, if I had something like 6 is less than 12, 6 is less than 12, the opposite of no solutions, all solutions, or all real solutions, or infinitely many solutions. And how you would graph that is you would fill in the entire number line. But in this case, no solutions, you don't fill in any part of the number line.